our last pair of speakers this session, Melissa and Rosie. The whole rainbow.
Thank you. Hello again, everyone. Rosie and I will be speaking today about our continued research into Victorian era bookcloth manufacture. Next slide. As you know, the Poison Book Project began with the discovery that arsenical emerald green pigment was used to produce bookcloth in the mid-19th century. This led me and Rosie to question what other potentially toxic pigments, fillers, or binders might have been used in commercial bookcloth production. And here you see a brilliant rainbow of potentially toxic elements. The more vivid and rich the color, the more likely it is that the bookcloth contains heavy metals. You can see that two very common blue colors here are not considered toxic on their own, but we've found that bright blue bookcloth is still quite likely to contain high levels of lead. Historical research indicates that lead salts were a popular mordant for dyed bookcloth, and lead may also have been used as an opacifying agent. Although we've identified one bookcloth containing mercury, we have not yet been able to identify the exact pigment using Raman. Most of the reds we've analyzed have actually turned out to be organic dyes or a mixture of organic dyes and chrome orange. Next slide. We do, however, commonly see vermilion printing ink used on the surface of bookcloth, as shown here in this illustration. Next slide. As you know, the term heavy metal can refer to metals with a high density, so a specific gravity greater than 5, or a relatively dense metal or metalloid that is toxic. By any definition of the term, we have found that heavy metals are quite prevalent in bookcloth. We've found quite a lot of iron, zinc, and copper, which are heavy metals by density, but are not considered particularly toxic. So they're not listed here on this slide. This slide lists the heavy metals found in bookcloth that do cause some health and safety concerns. Next slide. Here we can see a quick comparison of 3 different bookcloths. The earliest bookcloths were a dyed cotton fabric, and at left you can see the bookcloth fibers have been dyed with an organic green. At center, emerald green pigment has been added to a starch slurry that coats the surface of a bleached cloth. And this is a bookcloth manufacturing technique that developed sometime around the late 1840s to create a more durable product that was less prone to fading. And at right, chrome yellow and Prussian blue have been combined to create chrome green. This is lead chromate and Prussian blue, as we heard from Tim earlier. And this pigment has also been added to a starch slurry that coats a bleached cloth substrate. Next slide. The images on this slide compare emerald green, and chrome yellow bookcloths. So you can see that the emerald green bookcloth coating is visibly more friable than the other two. It's really abraded away from the high points of the weave. The chrome green and chrome yellow do exhibit some micro cracking, but they have not abraded in the same way that the emerald green has. And Rosie will talk in a few minutes about quantitative testing that supports this visual observation. Next slide. Before I turn things over to Rosie, I would like to point out that even in cases where a bookcloth's pigmented coating is stable during normal handling, conservators performing interventive treatment may be at increased risk of exposure. A common condition issue for Victorian era cloth bindings is splitting along the joints. Next slide. A common repair technique for such damage involves lifting the original bookcloth away from the underlying board in order to insert a new repair material underneath. And then the original bookcloth is then re-adhered. This technique involves extreme mechanical manipulation of the cloth that could cause spalling of any toxic pigment coating. And the technique also introduces moisture in the form of adhesive, which could cause migration and increased offsetting of the pigmented coating during treatment. I'll now turn things over to Rosie.
Thanks, Melissa. So since the start of the Poison Book Project, we've had a really fruitful relationship with the soil testing lab at the University of Delaware. They, of course, are very used to testing all kinds of heavy metals in people's soil. And so we decided, continuing from our work that we published in the Journal of the American Institute of Conservation, to try and learn a little bit more about the offset of these other possible toxic pigments compared to the work that we had done on emerald green. And so to do that, and you can read all about this in our JIC article, we'd used these two tools to kind of simulate handling and also treatment. So we used the cotton swab to simulate the removal of surface grime from the surface, and then we'd send that directly away to the soil lab for quantitative testing. And then we also used this pad, which is a 2 by 2 inch square pad, which we get one operator, aka Melissa, to do a single swipe with an even pressure along one of the boards of the books. And then we send that away to the soil lab. We also then take blank samples and send those away for comparison. So I just want to show you these results, which we got earlier in the summer, and we've spent the last a few weeks kind of pondering over them. So if we start on the right-hand side and looking at the arsenic offset, which we got a couple of years ago now, from Rustic Adornments, which was our first poison book that we found at Winterthur. There's a significant amount of offset, about 13 micrograms per kilogram. And this is just from one pad swipe across the surface. So the lethal dose for arsenic is around 5 to 50 micrograms per kilogram. This is what's quoted in the literature. So if you were to ingest somehow the amount of offset from that pad, then that would be around the lethal dose for arsenic. On the other hand, we did the same pad tests for Marion Augusta, which was a chrome yellow confirmed by Raman binding, and the Carteret, which is a confirmed chrome green binding through Raman. And the results were very different. So obviously we're not looking for arsenic anymore. We're looking at the offset of chromium and lead. And actually many of the results that we got were below the detection limit of the equipment that they were using in the soil testing lab. And so we're actually thinking about more sensitive techniques that we can use to identify these elements. So all of these results we're seeing here are from the pad tests only. We didn't get any response from the cotton swab tests on the chrome yellow and chrome green books. Also, for the Marion and Augusta, none of the results were above the detection limit for lead. So this is very good news in terms of the offset. Not only is there less offset of the pigment, both chromium and lead, from these books, but also we know that the lethal dose for chrome yellow, which is obviously the source of these pigments, is about 3 orders of magnitude higher. So not only is there less offset, but it's also less toxic for our health when we're handling these books. And I just wanted to remind us briefly of what Melissa just presented in terms of the friability studies, looking really close at the bookcloth. And if we think about the friability test that we did, this makes perfect sense in terms of the arsenic really flaking off the bookcloth cover, whereas the chrome green and chrome yellow are really they're completely what's the word? Yeah, they haven't broken up at all. And so this makes perfect sense. And I'll bring it back to Melissa to just wrap up with this slide.
We just, based on the amount of lead that we have found in so many bindings, and the fact that the lead is less easy to predict because it could really be found in any color, we just really have been encouraging our own library staff and anyone who's asked us questions about the storage and handling of these books. We do feel it's important to try to identify and isolate a book that may contain arsenic, but really any 19th century cloth binding should be handled mindfully, and you should avoid touching your face while you're handling it, and good hygiene should be observed afterwards. We, thanks to Jess's research, when Jess was a graduate student with us, we now supply the library and the library lab with this D-lead soap that removes heavy metals from the skin better than regular soap. We just feel it's a good cautionary precaution. Next slide. And just thank you. This slide gets more and more crammed, full of acknowledgements every time we talk about this project. And we're just so grateful for all of our funders and all of our collaborators and contributors. Thanks.